Hi guys, welcome to your Unit 2 review for transformations and congruence. So this review, if you were with me last semester, this review is slightly different than usual. I'm going to be mostly going over general concepts that we learned about, and I will do a few examples, but they're not going to be directly correlated with each problem, okay? So I'm giving you a little bit more ownership of your learning and a little less hand holding on my side, okay? Because we got to get ready for that, especially when it comes to high school. So let's see here. Let's get into it. I would say for sure pause this video, take notes down. That way you can have it in front of you while you are taking your test. You can also screenshot it and save it to your computer. That works too. But remember, when we write things down, our brains remember it so much more. Okay? So, transformations. That's the major thing that we learned about when it came to this unit, right? And so transformation means the changing of the location of a figure. Okay, so it went from one spot to another. And then we went into several different types. Okay, so translation was the first type we learned. And so it's when a figure slides to a new location, right? It just moves from one spot to another, but the size, shape, and orientation don't change, meaning like it doesn't, like there's no rotation yet, right? It still looks the exact same, it's just in a different spot. But it is very important to note that with a translation, the size and the shape don't change, okay? That's a big hint for your test. Only the location changes, and then first you slide left or right, so you signify like your X value, and then your up or down or your Y value when you are notating it, okay? We also learned about reflections. So a reflection is when you flip across a line, okay? That's the way you can think of it. You can also think mirror image, excuse me. And again, the size and shape do not change of the shape or the line, whatever it is, okay? But this time the orientation does change, right? Everything is backwards. So then I wrote down here, if reflected across the x-axis, the y value is the one that changes. If reflected across the y-axis, the x value changes, okay? So just a quick example. I didn't include other examples of reflections. I feel like you guys have a pretty good handle on these. But let's just say, I don't know, let me just draw a super fast graph. Let's say we have this point here, which would be 2, 1. Well, if I'm reflecting across the x-axis, here's my x-axis, right? I'm going to go across that. Then the point would come, would come down here to, it's still 2. So notice my my x value didn't change, but now my y value is at -1. So this would be an example of this one here, right? We went across the x-axis, so the y value changed. Okay, so keep that in mind as you go through your test and just really pay attention. And some of them are going to have graphs shown, some of them are not. And so just make sure that maybe draw like a really quick graph like that, right? It only took me a few seconds to get that down, but then I could actually visualize what's going on. So I would highly encourage you to do the same, okay? It's worth those extra few minutes and the tiny bit of extra effort. Okay, we also went through rotations, which for the most part, this is probably like the trickiest thing to grasp, especially if you're not good at visualizing changes like this. Okay, so make sure you write down the rules. And the rules, they might not feel super obvious either. You're kind of like, oh my gosh, like none of this makes sense to me. But just pay attention to what you're doing Take your time. Don't rush it, right? Figure out, what is the question asking me? Is it asking me for a 90-degree clockwise rotation? Well, then follow this rule. Is it asking me for a 270 degrees clockwise rotation? Follow this rule, right? Like, figure out what is it asking of me, and then go from there. I am going to do 2 examples of this, and so hopefully that will help as well, okay? 180 degrees rotations, it doesn't matter which direction you go, clockwise or counterclockwise, either one, the change is the same, okay? So, and also, I should probably make note of this just in case. A clockwise rotation is going to the right. Counterclockwise is going to the left. Okay? So that's important to note also, which, depending on what kind of clock you have in your house, maybe you wouldn't realize that that's what that means. Okay? I know a lot of us use digital clocks now. So the other thing that we need to think about, and you're going to see this on your test, but also from here on out in your math classes, we need to be able to recognize what quadrant we're in when it comes to the coordinate plane. So remember, this is your y-axis, this is your x-axis. Right here, this is quadrant 1. Everything is positive in quadrant 1, right? All of your x values are positive, all of your y values are positive. Quadrant 2 goes to the left over here. Your x values are negative in quadrant 2 and your y values are positive. In quadrant 3, everything is negative. Okay, x values are negative, right? We went to the left on the x-axis. We went down on the y-axis. In quadrant 4, we have oops. Oh my goodness. Sorry, my dog is barking and it's distracting me. And, so our x values are positive and our y values are negative. Okay? So you got to think about this because it might tell you the figure in quadrant 1, or how do we get from the figure in quadrant 1 to the figure in quadrant 3? Right? Well, so you need to know which one is quadrant 1 in that case. Like, where am I starting and where am I ending? Okay? So that's something to think about. I've got 3 examples for us. 2 of them are rotation examples, and then one where we're like describing the transformations. So this first one, it says rotate point 1, -4, 90 degrees clockwise around the origin. Well, first I need to find point 1, -4. So that means I'm going 1 to the right and down 4. So, and I'm going to label this, I'll label that as point A. So there's point A. So if we're going clockwise, that means we're going to the left like a clock. And if we're going 90 degrees, that means I'm going from, in this particular case, quadrant 4 over to quadrant 3. Okay? Now, if we are using what Mr. Ismari would say, like just our common sense, we could think, okay, it's 4 away from the origin right there. So over here, I would need to be 4 away on the origin. And then it was in 1. So if I'm 4 away from the origin over here and in 1, that would look like that. So this would be a prime. Now, if we're considering the rules that we learned, let's look at both ways. Let me pull up the rules because I don't have them memorized. Okay, so a 90-degree clockwise, the rule that you learned, and that what is in your lesson and what's on the page before this that we talked about, is that whatever you started with, these are your original x and y's. Okay, so this would be like for A And then A prime would be y negative x. And notice that is what happened. For us, we had A at 1, negative 4. Well, now my x value is negative 4. And my y value is negative 1. Well, let's look at this. So this was my y value over here, right? Negative 4. And there's my negative 4. Those match up in both points. And then here, my x value was originally 1. Well, now it needs to move into my y value, and I need to take the opposite of it, which would be negative 1. So either way you look at it, whether you use like that just common sense, like where am I going? What does it mean to go 90 degrees? Either way, hopefully you can see that rotation, okay? Or if you can't see it, then use those rules. Right, but notice that looks like about a quarter of a circle, right? That's what a 90-degree turn is, a quarter of a circle, and that's right where we're at. So hopefully that helps. With number 2, we're going to rotate a line segment. We have line segment AB around the origin. We're going 270 degrees clockwise, okay? So 270 degrees clockwise. And where AB's endpoints are 2, 3 and 1, 2. So let's go ahead and get that plotted. So 2, 3, about right there. And then 1, 2. That's just a little guy. Right, so there was A, and here's B. So if we're going to go 270 degrees clockwise, okay, there's a couple things that we can recognize. One, we could go 3/4 of the way around the circle if we wanted. Okay, that would, we're in quadrant 1, we would end up in quadrant 2 if that's the case. But we can also consider that as a 90 degrees counterclockwise rotation. Let me make like a little mini coordinate plane down here. So like if we're right here, 270 degrees clockwise would get us here. 90 degrees counterclockwise gets us to the exact same spot, making that full circle. So without even having to go 3/4 of the way around, let's just go 90 degrees, okay? So a 90 degree counterclockwise rotation, the rule that we learned, you have your original x and y, and then you're moving to negative yx. Okay, so for each of those, for 2, 3, I'm going to write these out. So before I even come over here and do the logic version, I'm going to do this one for those of you who prefer the rule, okay? So if this is my logic, let's see, 2, 3, and then 1, 2. Let's just focus on point A. Well, in this case, my x value moves to where my y value was. And then I'm going to take the opposite of my y value and move it into my x value. So that would be negative 3. So let's see what that does to point A. So negative 3, 2. So that means I'm coming over here and going up 2. Okay? So that would be A prime. This was 2, 3. Now we're at negative 3, 2. Okay? With the next one, for 1, 2, point 1, 2, that's this one here. Well, my x value is going to become my y value, and my y value becomes my x value, but I take the opposite of it. Okay? So that puts me at -2, +1. Okay, and hopefully you can see that 90-degree rotation. All right? You can see it kind of went zoop, almost like it's like a hand or something rotating in that circle. Okay? So hopefully that helps you with those 2 rotations. But again, when in doubt, use those rules that we learned. The final question that we'll go over today that should hopefully help you and kind of bring everything together is this one here, number 3. Describe the series of transformations that were used to transform A, B, C, D, that's that rectangle, to A double prime, B double prime, C double prime, D double prime rectangle. Okay? So we're going from this one to this one to this one. And this one we don't have to put points or anything like that on this one. What we're doing is we're just saying first this happened, then this happened. So in this particular case, one of the most important things for you to notice is that everything flipped over. Do you see that? So A was in the top left, now it's in the bottom right. So what would do that would be that rotation. Okay? So first there was a rotation, but then notice now A prime is in the same location as A double prime. So what that tells me was that this just slid down. Okay? So for this one, the answer would be first there was a rotation, then translation, right? So it rotated, so it turned, and then it slid. Okay? So that's important to be able to consider. Okay? Let's see. I was going to say something now, I can't think of it, but I think that was it. If you need extra support, let me know. And as always, if the test doesn't go well, we can always do corrections. Okay? So reach out to me if you need extra support. Otherwise, good luck on your test.